All right, today we're going to find how we're going to find the centroid. All right, one of the things, if we're given a xy coordinates, let's suppose here, I'm pre-drawn right here, we have at the origin we have a 0, 0. Remember, this is an x, y, and over 1 up 6, and then over 5 up 0. All right, the way to solve this is quite fascinating. It's a very easy thing. So we do x1 plus x2 plus x3 divided by 3, and that will give us my x coordinate of where the centroid is for this. Well, we'll just make this right here, we'll make this into a triangle, all right, which is remember we did that was the balance point or the center of mass, and then we have the y1 plus y2 plus y3 all divided by 3. Now all I got to do is substitute in here. So my first x, so let's just go ahead and put these right here in order. So my first x is going to be a 0, plus my second x, which is a 1, plus my third x, which is a 5. All right, that's all divided by 3, comma. Let's go here and look at the the y coordinate. The y starts over here with a 0, y1. y2 goes all the way up to 6 here, so that's going to be plus 6. And then I go over to y right here, that was going to be a 0 for y3. All right, that's the same thing as 6 over 3, comma, 6 over 3, which is the same thing as 2, comma, 2. All right, and so that's my coordinate. So if you look at right about here, this is where I would have a median, and I have another median right about here, and so another median would be right about here. And if you look at that, that's about over 2 up 2. So again, I don't have the full grid there, but this is the way to be able to find the centroid when using a grid. All right. Now, I'm going to talk a little bit extra also length about finding the medians. All right. We have the length. Remember the centroid or the median of a side is the middle of the side connected to the opposite vertex, and I've done this the same thing. Remember when I did my construction, we used the perpendicular bisector to find the center, and then from the center you connect it to the opposite vertex. But for discussion purposes, let's say that this length right here is x minus 2, and this distance that's from here to here, and then this distance from here to there is 2x minus 5. Well, if we know if they were asking us to find what x is, then we'd have to set up an equation. Now, if this represents this half and this half, we know that they both two halves are going to be equal to each other. So I'll just put my minus 2 x minus 2 is going to equal a 2x minus 5. I'll bring this guy over there, so that's going to be an x. Bring him over here, which is a plus, so that's going to end up being x is going to be equal to a 3. All right. Now, as you recall, in the construction of the centroid using the medians, if we have one side, this distance right here is 2/3, and this is 1/3. All right. So if I have a distance of let's say this distance right here is let's see. If this right here is 2x minus 4, this distance right here is 2x minus 4, then, and we have a distance over here as a 9, this distance right over here is going to be, I'm going to move that over here, is a minus 9 plus 2x. Now, I've got, remember, this is 2/3, and this is 1/3. So I've got to set up an equation between these right here. Well, this right here is essentially half of that. So the easiest way to set up an equation, I have to use an equation, of course, to find out what x is. So I will have to, if I multiply this portions by 2, it will equal this, okay? So I'll go over here, right over here. So I've got my minus 9 plus 2x, all right? And I'm going to multiply that all by 2. So I can have 1/3 times 2, which is 2/3. It will equal 2/3. Will equal my 2x minus 4, and then I distribute, and I get it a minus 18 plus 4x equals a 2x, I think it's a minus 4. I bring this guy over here, so that's a 2x. Bring this one over there, so what is that? That is 18 minus 4, so that's got to be a 4, right? 14. Yes, 14, so x has got to be equal to a 7. All right. Did I do this right? I think so. Okay. So then we solve for x in that case. Now, another one, a little bit more difficult. Let's say that the length, I'm going to work with this one right here, all right? The length from all the way to here, all right, from there to there, remember that's going to essentially be 3/3. So let's give an example of one here of all of this distance from here to here is going to be 2x minus 1. I'm just making this up for the time being right now, right? So that's 2x minus 1. Now, this leg from here, all right, is going to be, let's say this one right here is, this portion right here is going to be, I've got to find something to make these equal, all right? I haven't set them equal yet. This entire length is 2x minus 1. And then this distance from here to here is going to be, let's do a 3x minus 9, okay? Now, I've got to set up an equation, or I know that all of this right here is 3 over 3, that's the whole length, where this right here is only 2/3. Now, what can I multiply by times 2/3 to get 3 over 3? And we just do the reciprocal of that. So, well, in order to make my equation, I have to now multiply this right here by the reciprocal of this, which is going to be 3 over 2. All right. All right. Now, if I to solve this right here, one way to do this would be to cross multiply. So this would be a 4x minus 2 equals 9x minus 27. And if I bring this guy over here, so that's going to be a 5x. And I'm bringing him over here, so that's going to be a 25, right? Yep. Is that right? Plus 25. So x is going to be equal to being 5. All right. So this is one of the ones that's really actually a little bit more difficult. But as you can see, the centroid, the center point is the balance point. And it means that from this distance from here to here is going to be 2/3, and from there, there's 1/3. But in order to solve these x's to find the length, you've got to set up an equation. And in other words, you've got to find a way to make them equal. Hopefully that's not too confusing. And there's a lot to be dealt with there. But that's a little bit about finding the centroids and the lengths on the medians. Thank you.